Hello, good morning. I would like to introduce myself to you. I am DwinantoSukamto. Today I present to you my work on thermal performance evaluation of a biclimatic ventilated wall using a hot box. First, I will present the agenda of my presentation. First of all, I would like to present to you context and objective of the study. The second, I will explain the presence of the experimental setup, and third, I will describe the result of experiment, and at the end, I will present the conclusion and the perspective. For the context, I just want to outline the one of this picture. That official website of Batimong are energy positive stated that climate change is the major challenge facing the world in the future. So, in this context, France is placing the construction sector at the heart of its strategy to meet this challenge. And the other, I would like to present the objective of this study is to characterize the thermal performance of bioclimatic ventilated wall. An original system has been set up for experimental study of a bioclimatic ventilated wall. And also I would like to present the benefit of the ventilated wall as an envelope solution over a wide variety of exterior cladding, ability to select a wide variety of material, color and panel size, and to protect the insulation material by dissipating moisture. That is already general. And this here you can see the typology of the ventilated wall in the literature. For example, ventilated envelope, double skin facade, building integrated photovoltaic, solar chimney, solar wall, and trombe wall. And there are two parameters adequately characterize the major working principle: the origin of the airflow and the driving force of the air. Next, I would like to present you our ventilated wall. Our ventilated wall consists of two types of wall. One type wall is, we call it fixed wall, and the other is moving wall or mobile wall. The mobile wall allowing the thickness of the ventilated cavity to be varied, and there are one thing is ventilated air chamber. The property of material, as you can see from the slide. And right now I would like to present the hot box equipment that we use for our experimentation in laboratory. First, the hot box consists of two climatic chamber and one specimen holder. The first climatic chamber we set as indoor condition, which we call the climatic fix, and the other we set to the temperature of outside condition, and we call it the mobile chamber. And this hot box can produce range temperature from minus 30 to 60 degrees Celsius, and range of humidity from 10% to 98%. Also, I would like to introduce our thermal metrology that we developed for doing the experimentation. The thermal metrology are Catlade 2700 with 60 channel, and there are thermocouple Tipka with the range temperature minus 75 degrees Celsius to 250. There are also flux meter with uncertainty 5%, and there we are use also the thermal camera. Here I would like to briefly explain the data acquisition, our system. So we are introduce our system of acquisition that the control computer take the important role in our experimentation, because he connected with data acquisition and he regulated the hot box. And the data acquisition of Catley, there are thermocouple Tipka and flux meter, and the other there are thermal camera FLIR, which direct connect to the control computer. We are also use DC control power supply to regulate the airflow through the DC fan, and we have an DC axial fan which installed at the round insulated ventilation duct, and there is also a hot wire anemometer to measure the airflow at the outlet of the experimental device. The quantity of airflow is recorded at the central computer by National Instrument. And inside the two climatic cells, right now I would like to present the climatic cell instrumentation. As you can see from the photo, inside the two climatic chamber we installed 3 PS of TIPCA thermocouple inside each climatic cell. The position of this type thermocouple is in the middle of the climatic cell. Inside the fixed cell, a thermal camera FLIR T650SJ, and after installation of TIPCA thermocouple inside the cell, next will be described instrumentation to the test specimen of sample instrumentation. As you can see from the picture, to characterize the thermal behavior of study sample at the level of each wall, we have 12 thermocouple, 1, 2, 3, and 12 thermocouple, and 4 flux meter were installed on 4 level different height and are equally distributed over the within. For air temperature measurement, there are 3 thermocouple at the entrance of the cavity, and another 3 at the outside of the cavity, and we are also installed in the middle of the air chamber for PS of thermocouple. For experimental setup in the laboratory, we use the setting 20 degrees Celsius 55 for the hot cell part, and then for the cold cell we set it to the 0 degree and 75%. In the middle we have a specimen holder, and we do the variable airflow rate 10, 20, 30 meter cubic per hour, and variable airspace thickness from 5 millimeter to 85 millimeter. And here I would like to introduce the ambient temperature in cold cell and in hot cell. As you can see, the blue and the red one, the blue is represent air temperature in cold cell and in hot cell. And as you can see, there are different measurements from the hot box sensor and the thermocouple sensor. The hot box sensor is overestimated in measure by 3 degrees for the mobile cell and 4 degrees for the fixed cell. This inaccuracy can be explained that the cells are not airtight since an artificial airflow has been created between them. However, for the standard use of the hot box, there should no air exchange between the cell. The thermocouple and infrared camera measurement represented by this graphic, and this represents our fixed cell, our fixed wall, and at the fixed wall there are installed thermocouple T8, which represent with the red, T5 which represent at the blue color, and temperature thermal camera which represent with the yellow graphic. And the area of the surface measurement of the thermal camera is 10 centimeter square. And then as you can see from the graphic that we have different between thermocouple and the thermal camera is 0.05 degrees Celsius, and it can be said that the measurement of surface temperature by thermocouple are inadequacy with the measurement made by infrared camera, and confirm the reliability of the instrumentation of the wall. And here I explain to you the temperature evolution for configuration air chamber 50 millimeter and 10 meter cubic per hour. This graph represents the evolution temperature inside of the ventilated air chamber. The round shape represents of airflow 10 meter cubic per hour. The square shape represents airflow of 20 meter cubic per hour, and the rectangle represents for the airflow 30 meter cubic per hour. The point measurement at the represent as a function of the vertical position from 001 to 0910 meter at the vertical level, starting at the 001 to 0345 meter, that we see the evolution of temperature nearly close in order of value. The temperature of airflow from 0345 to 0910, it's start to be vary that the airflow 10 meter cubic per hour slightly bigger than airflow of 20 meter cubic per hour. This indicates for the airflow 10 meter cubic per hour, the air getting preheat more than the other airflow. We considered to present the convection heat transfer coefficient, and we used to estimate the parameter. We used the formula Newton. According to this relation, the estimation of convection heat transfer required knowledge of heat flux and the ambient air temperature, and also the wall surface temperature. From the figure or from the graphic, we show the estimation heat transfer coefficient at the wall surface in each of cell and for different cavity thickness and flow rate. From the figure, it's really see that with the blue color that different. Our analysis of this condition are, we believe, this problem related to the flux matter which were only partially in contact with the wall during the test. We have corrected this defect for the other experiment. In general, the coefficient of heat transfer on each wall are 24 for the hot cell and 15 for the cold cell. 24 for the cold cell and 15 for the hot cell. The uncertainty for we talk about Nusselt number. The Nusselt number represent in this graph is the value of inside the Nusselt number inside ventilated air chamber. The round shape as usually represent of airflow 10, 20 and 30 for rectangle. The color in graph represent of the blue color represent the Nusselt number inside of air chamber near the mobile wall, and the other red color represent Nusselt number inside of air chamber near fixed cell, and the black color represent the global value of the Nusselt number inside the air chamber. The Nusselt number is depend on the required estimation of convection heat transfer coefficient, required characteristic length, and the thermal conduction of the fluid. The Nusselt number inside the air chamber near the mobile cell slightly bigger than the Nusselt number inside the air chamber near fixed wall. Based on the Nusselt number value, the value for conditioned air chamber distance 50 mm at the airflow 30 meter cubic per hour is slightly big than the Nusselt number for airflow number 20 meter cubic per hour. For the purpose of this study was to investigate the thermal performance of ventilated bioclimatic. For the reason a hot box thermal metrology was developed specifically based on experiment tests. This study discussed the experiment setup and the thermal metrology data collected from the hot box used to estimate the convection heat transfer coefficient of the ventilated wall, and the study was completed by an analysis of the measurement uncertainty which proved satisfactory. Thank you very much.